All right, Algebra 2 and pre-AP Algebra 2. We're going to double this one up today. We're going to talk about mastering factoring. All right. So we're going to factor each of these expressions, and we're going to notice possibly some similarities, right? Okay, so here we go. With this one, guys, this is indeed difference of squares, right? So that means that this is the same thing as x squared minus 1 squared. So one way that you can look at it is you could use the formula that tells me that a squared minus b squared is equal to a minus b times a plus b. Okay? So in this case, right, a is x. So we could say that a is x and b is 1. And we can just plug that in there, right? So that would give us x minus 1 times x plus 1. Guys, I can also prove that to you using the Xbox method, right? Because another way of looking at this, right, we have this x squared, right? So that means that, and this negative 1. So that means that we have a negative 1 on the top. And there's no x term, so that means that we have a 0 on the bottom. So we're also, another way to look at this is to think of two numbers such that if I multiply them, I get negative 1, but if I add them, I get 0, so that would be negative 1 and 1. And that's how that thing factors. Let's look at B. Again, this is difference of squares, and that's going to be my preferred method of looking at this, right? So the square root of 9 is 3. Right, so I'm going to write this as 9x squared minus 1 squared, right? So what's my square? I can rewrite this, right? Isn't that the same thing as 3x squared minus 1 squared? So now that I've done that, I know what my a and my b are, right? So a would be 3x and b would be negative 1. And then I can just plug them into this, right? So that would give me 3x minus 1 times 3x plus 1. And if you FOIL that thing out, you're going to see that clearly those two things are equivalent. They are the same. Let's look at these next ones here. Let's factor. So, I am looking at this thing. So I'm going to go ahead and get out my x, right? My little tool that I use. So 15 in the top, right? C in the top, or a times c really in the top. And then b goes in the bottom. Remember, that's a times c, and this is b. And two numbers such that if I multiply them, I get 15, and add them, I get 8, would be 3 and 5. And I don't need to get out my box because the coefficient of x squared is 1. So that is going to be equal to x minus 3 times x plus 5. All right, let's look at D. Little different. I think we're going to have to get out our x and our box, right, for this one. So up here on the top, I have 4 times 15, which is 60. And in the bottom, I have 16b, right? So that looks like 10 and 6 work there. I'll get out my box. And over here, I'll put my 4x squared. Right here, I will put the 15. And then remember, the 10 goes here and gets an x, and the 6 goes here and gets an x. Greatest common factor of 4x squared and 10x is going to be 2x. The greatest common factor of 6x and 15 is going to be 3. The greatest common factor of 4x and 6x is going to be 2x. The greatest common factor of 10 and 15 will be 5. So that means that this thing factors and becomes 2x plus 5 times 2x plus 3. We should all be experts at that by now. Let's see, what's similar about that? Well, it looks like those two are the same. Between C and D, they look very similar. We have a coefficient of 2 out in front of my two x's in my binomials. Interesting. All right. Well, what about this one? Well, in this case, I'm going to really definitely want to use difference of squares, where a is going to be, where a is x and b is y. So that's going to be equal to x minus y times x plus y. And it's really, really good for you to be able to see that difference of squares and practice using it. Okay? Here we go. And the next one, well, hey, can I rewrite this as x squared to the second power? So x squared squared, right? Minus y squared squared. And that would mean that my a for my difference of squared formula is going to be x squared, and my b would be y squared. So that means that I can call this x squared minus y squared times x squared plus y squared. There it is. All right, so let's write 9 minus 16x to the fourth as the product of two factors. In other words, it's going to be the product of two binomials. We're going to do that to it, right? That's what's going to happen. So again, I would need to identify what is A and what is B in this thing. And if I rewrite it, so that I write this as 3 squared, right? Minus 4x squared. Now I can use this formula, right? This formula that I mentioned before. A squared minus b squared is equal to a minus b times a plus b. We'll just plug a and b in there because now we know that a is 3 and b is going to be 4x squared. So a is 3. A is not A. A is 3. And b is 4x squared. And we can plug those into our formula. So we have 3 minus 4x squared times 3 plus 4x squared. And there it is. It's the product of two factors, right? This is one of my factors. And my other factor is that one. Super. Hello, Mr. Norman. Am I late? Oh no, Dr. Brahmgupta. You did come. I didn't think that you were coming today. Well, I am very late, but I am come. It was my rickshaw. My rickshaw had a broken wheel, and now I'm here. Okay, well that's fantastic. I didn't realize that we had rickshaws in Rio Rancho. But that's fantastic. Awesome. Would you like to step in and work this problem? Very much so, I would like to. So, as Mr. Norman was saying, we are going to use our difference of squares, but in this case it is kind of difficult for us to see what our squares are going to be. So I want to write this in the form that this is a squared minus b squared. So I must figure out what is a and what is b. So let's look at this. 4x squared times y to the fourth power. Well, what is square root of 4? This is 2. What is square root of x squared? This is x. And what is square root of y to fourth power? It turns out to be y squared. So I can use all of these terms in order to find what my a is. So then I would write this as 2 times x times y squared. And we can know that this is true because if I was to raise everything up into the second power, I will write this someplace else. If I was to do it, I could say that this, it is going to be quite equal to 2 squared times x squared times y squared, which is 4x squared y to 4th power. And so that is going to be my a. So that's a minus b. I need to figure out what my b is. What is the b? Well, what is square root of 5? 25 is 5. What is square root of x to 4th power? It is x squared. I am simply dividing. If I take the square root of something with an exponent, I am simply going to be dividing the exponent into half. So x4 becomes, if I divide 4 by 2, it becomes 2. And if I divide the 6 by 2, it becomes z to 3 power. There it is. I should have written it over here. So here it is, 5x squared z to 3 power. Oh, the bell has rung. I will need pause and wait for your class to finish, Mr. Dorman, and then I will come and finish this problem when the children have all left. Thank you so much, Dr. Brahmagupta. I love that you're being patient today. Very well. So now that I know what A and B are, I can write it as the difference of squares. So this will be 2xy squared minus 5x squared z cubed times 2xy squared minus 5x squared z cubed. And there it is, it has been factored, and now I will leave it to you, homeboy, Mr. Dorman. Oh, thank you very much, thank you. All right, we will have you come and do another problem here in a second. Let's factor this one then. All right, so let's go ahead and factor this one. All right, so I'm going to get out my Xbox method. I can see that this is a quadratic. And then up here I will have 63 times 4, right? A times C, which is 252. And then on the bottom I will have my B, which is positive 4. And I need to think of two numbers that if I multiply them I get negative 252, and if I add them I get 4. Those two numbers will be positive 18 and negative 14. There they are. Oh, your bell has rung again. Oh, interruption. Interruption. You're interrupting, Dr. Brahmagupta. Stop it. All right, so now I'm going to get out my box. And I'll put my 4x squared here. Negative 63 goes here. 18x here, negative 14x here. The greatest common factor of 4x squared and 14x is going to be 2x. The greatest common factor of 18x and 63 is going to be 9. The greatest common factor of 4x and 18x is going to be 2x. And the greatest common factor of negative 14x and 63 is going to be 7 negative. So then this factors to 2x minus 7 times 2x plus 9. No problem, right? Oh, that was very easy. You do so very good. Thank you, Dr. Brahmagupta. All right, let's do another one. Well, the first thing that I see is that these three terms, oh, those three terms, quit interrupting me. These three terms have a common factor. It's 3. So I'm going to factor out a 3. And that's going to be much, much easier for me to factor now. So I'll get out my x. And the 3 is not going to be involved in my Xbox method. I'm just factoring it out. So up on top, I'll put negative 20. Up on the bottom, negative 8. Two numbers that product is negative 20 and their sum is negative 8 would probably be negative 10 and 2. So let's go ahead and get out our box. 4y squared minus 5 minus 10y and then 2y. The greatest common factor of 4y squared and negative 10y is going to be 2y. The greatest common factor of 2y and negative 5 is 1. Greatest common factor of 4y squared and 2y is going to be 2y. And the greatest common factor of negative 10y and negative 5 is negative 5. So this is going to be equal to, don't forget that 3 that we pulled outside. We are factoring, we're just factoring. So I can't get rid of the 3 like I could if I had an equation where I could just divide both sides by 3. In this case, it's got to stay there, or else I haven't factored it quite right. And there it is, it has been factored. Let's move right along. Alright, so in other words, this says, right, so if I need to factor each, I need to factor it and then show that it's equivalent to the original. All you would have to do is multiply. I know, all I would have to do is multiply it back out. Dr. Bromwood. Alright. Ooh, what do we got here? We have something different. These are cubes. Dr. Bromgupta, would you do me a favor? Would you tell me the equations that I would use for difference of cubes and sum of cubes? I can. These equations are quite simple. Just make sure that you have them written down. Here we go. I have, first I have difference of cubes, which means that a cubed minus b cubed is going to be equal to a minus b times a squared plus ab plus b squared, and that is it. You will use this equation. The next one I like to call sum of squares, and that is a plus b times a squared minus ab plus b squared. That is the formula which you must use for every one of these when they have a square, a cube. Here we go. I would like to do, you didn't even ask if you could do a problem. I'm going to do it anyways. Okay, so first thing I would like to do is to identify what is A and what is B. So I would like to write this in this way. This is A squared plus what is cube root of 27? But 27 is 3 times 3 times 3. So that must be 3 cubed. So then it is the case that A is equal to A and B is equal to 3. And I will plug them into my equation which I have over there for sum of cubes. So that will be equal to 8 plus 3 times, well, 3 squared, a squared. Oh, I made a mistake. So that would be a squared minus 3 times a plus 3 squared. I will simplify these things. A plus 3 times a squared minus 3a plus 9. And I believe that I have factored it in its entirety. Unless I can think of two numbers such that when I multiply them together I get 9. And when I add them I get 3. And there are no such two numbers. So it is completely factored. Very, very good. Well, thank you so much, Dr. Bromgupta. I want to do the next one if I can. That was fantastic. Here we go. So I'm going to write this as x cubed. And what is the cube root of 64? It is 4. So then, and let me scroll this up so I can look at the equation that I have here. Right. I'm going to use my difference of cubes on this, right? So in this case, A is x and B is 4. So I'll plug that in there. So this is going to be x minus 4 times x squared plus 4x plus 16, because 16 is 4 squared. There it is. Done. All right. Well, what in the world am I going to do with number 4? Oh, I think you're going to have to factor out a 2. Shh. Quiet. I'm teaching. I am going to factor out a 2, though, Dr. Bromgupta, you're right. So, when I factor out this 2, I wind up with 2x cubed plus 128 divided by 2 is indeed 64, and that works nicely because I can write this as 2 times x cubed plus 4 cubed, and then I'm going to use my difference of my sum of cubes. I'm not going to forget to leave my 2 out there, right? So that's going to be x plus 4 times x squared minus 4x plus 16, and there it is. I have factored it. But, okay, are there two numbers such that if I multiply them, I get 16, but if I add them, I get 4. So factors of 16, 2 and 8, that doesn't work, and 1 and 16, and that doesn't work. So that is indeed factorable. I have 4 and 4, but that's going to give me 0. So that is very good. We've done it. And that's it. Hey, thank you for watching, everybody. Thank you very much. I will see you again some other time. Thank you, Dr. Bromgupta. Thank you so much. See you next time I see you guys. Thanks for watching. Well, that was so much fun. I wish that we could do it. Shh. Finish recording.